everyone, my name is Aryan and welcome back to Inside Out. Today I'm going to do a video about windmills. So let's get started. Okay, so let's get started. How do windmills work? By Aryan. So first let me talk about what is a windmill. A windmill is, as you can see in the background here, there's like hundreds of them. They're basically giant like sticks with three like blades that spin using the wind. So they spin like this, and there's hundreds. It's called a wind farm. So when the wind comes, it spins those blades, and when it spins, it makes electricity that comes all the way to our house. So I'm going to talk about wind uses right now. Wind flow patterns and speeds vary greatly across Canada and are modified by bodies of water, vegetation, and differences in terrain. Humans use this wind flow or motion energy for many purposes: sailing, flying a kite, or even generating electricity. The terms wind energy and wind power both describe the process by which the wind can be used to generate mechanical power or electricity. This mechanical power can be used for specific tasks, such as grinding grain or pumping water. Or a generator can convert this mechanical power into electricity too. So these in what uses this topic, they basically it's trying to explain that like what can you use wind for? Use like wind for riding a sailboat, flying a kite, or like not sure, like whatever it says, making electricity. And also you can complete specific tasks like if you're trying to get some electricity, like if you need to charge something, you can also use wind power to do it. So now we're going to talk about how does a wind turbine work. Okay, so like a wind turbine turns wind energy into electricity using aerodynamic force from the rotor blades, which work like an airplane wing or helicopter rotor blade. When wind flows across the blade, the air pressure on one side of the blade decreases, and the difference in air pressure on the other two sides of the blade create both lift and drag. So basically what that means, like at a helicopter. So in a helicopter, there's one thing that on the top there's no air. It tries to take the air from in there, and then from the bottom of the helicopter blade, it pushes it all the air down so fast that like lifts it up. Like same with an airplane rotor. It's like it's like a windmill, but in a bigger size. A windmill. So airplane motor would take the air from the front and push it back. So then the airplane will be going forward and up, and produces a drag. So yeah, that's basically what that means. Like the force of the lift is stronger than drag, and this causes the rotor to spin. The rotor connects to the generator either directly or through a shaft and a series of gears that speed up the rotation and allow for a physically smaller generator. This translation of aerodynamic force to rotation of generator creates electricity. That must be very complicated. Let me tell you in a simpler way. So first, like here, you have like a wind turbine. Do you see? Wind turbine, one, two, three. Yeah, the stick. So this will, yeah, that's a better stick. This is the wind turbine. First wind comes from the front here. So when the wind comes up, this is sucking up the wind. You see? While it spins. And then in the back, this all the wind comes out. Super hard. Like that. And then also with this, it goes in, all the wind. While it spins very fast, so then it shoots out. Like that. All same for here, the wind will go in here and then shoot out. So it's like very like that. And then while that, oh great, clear my entire screen now. My windmill, no, come back, please. I worked so hard earlier. Oh, good, you're back. Okay, so then So while this spins, there's actually a coil in here in the middle. When it spins super fast like that, the coil and there are also some magnets which move very fast, which creates electricity. So then all the electricity from here goes down, 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 and goes all the way down to the ground, and it comes all the way here and explodes all the hay. I mean, you could do that. You could explode the ball of hay, but also like light up a light bulb. Like, see up there? That's my light. So there, you can see that's my light up there. So up there, the electricity comes from all the way from these windmills right here. So electricity goes underground. You can see the green thing from the hay. Maybe not in the hay. Goes all the way here and all the way up to my light. Also known as my house. So that's how electricity comes. So electricity could go to other people's houses and otherwhere, and it could take electricity everywhere. And and electricities are usually in different areas, like in very open places, like in wind like farms. Farms would have like a lot of like empty space, so it's a good place for wind because no wind will be blocked. So that's why they call it a wind farm. And a wind farm, you put it on a farm, and I have hundreds and hundreds and hundreds of windmills. There's a lot of windmills. Okay, so now go back. How do you clear my screen? Oh, there, clear screen. Okay, so now I'm gonna go to the next one, land-based one. So we have actually different types of windmills. So land-based wind turbines range in size from 100 kilowatts. And if you don't know what a kilowatt is, it's basically, you know how many kilometers? It's basically that in electricity form. That's what they call it, kilowatts or watts. So a land-based wind turbine ranges in size from 100 kilowatts to as large as several megawatts. You can see usually a light bulb would be produced by 50 watts. That means electricity. So 50 watts, you have like 100 kilowatts and several megawatts. You can tell which one's bigger, kilowatts or megawatts. Which one? This one or this one? It's this one. Megawatts. Megawatts are bigger because they produce more electricity. I always keep clear. I forget to clear my screen. There. Okay, so this is so megawatts always produce more electricity. And larger wind turbines are more cost effective and are grouped together in wind plants, which provide bulk power to the electrical grid. So you can call it a wind plant. So you can call it that or a wind farm. They're basically the same. So that's what's a land-based wind. But this is something that you must have not heard. Offshore wind. Maybe you can't see it, so let me just remove my picture there. So as you can see, offshore wind turbines tend to be massive and taller than the Statue of Liberty. So you know the Statue of Liberty. I think you must know what it is. It's a very tall statue. Yeah, it's a very tall statue. It's called the Statue of Liberty, and it came from France. You must know that. And offshore wind, they do not. Offshore wind does not have the same transportation challenges of land-based wind installations, as the large components can be transported on ships instead of on roads. Building a windmill has parts, and parts take you have to get first the base, and then you have to get one stick, and the other turbine, and then the other turbine to make one full one. At sea, you don't have roads or trucks. You have to make them at sea. That's very difficult because of all of the large winds. So do you see these? These are the turbines, and do you see these yellow things? These are good for them because these go all the way to the bottom of the ocean, and they anchor them down into the rocks so this won't fall over in all the high winds and all of the waves. And also, they also have some wind turbines which actually float on top of the water but don't flip over. I know that's kind of weird, like they're on top of the water but they don't flip over in all the waves and wind. So that I still don't know about, but I'll figure out that one day and tell you guys. So this is what offshore wind is, and also in the offshore wind, they produce more electricity than on land wind miles, because on in the ocean there's a lot of wind, like massive waves produce a lot of wind, so the wind turbines will move than like faster than onshore wind. So they produce more electricity, and all how all the electricity comes is actually it's basically the same. So the windmill has a wire that goes to the bottom of the ocean and goes from the ocean floor, which are waterproof wires, so it doesn't electrify the water. So then it goes up to land and gives electricity to us. That's how our house lights work. That's how my computer charges, or how my light that's right now shining on me like crazy works. So that's how energy works. And now we're gonna watch one video about windmills. So let's watch it right here. It's called energy. Let
We've
me
all
just.
seen those creaky old windmills on farms. And although they may seem about as low tech as you can get, those old windmills are the predecessors for new modern wind turbines that generate electricity. The same wind that used to
So
pump
as
water
you
for
can see
cattle
here,
is now
wait. Let
turning
me just
giant
restart this. No, wait. Technical
wind
difficulty.
turbines to power cities
Wait.
and homes.
There we go. Now you can watch it.
We've all seen those creaky old windmills on farms, and although they may seem about as low tech as you can get, those old windmills are the predecessors for new modern wind turbines that generate electricity. The same wind that used to pump water for cattle is now turning giant wind turbines to power cities and homes. Okay, have a look at this wind farm in the California desert. A hot desert next to tall mountains, an ideal place for a lot of wind. Here's another one on the windy prairies of Wyoming. Now, today's wind turbines are much more complicated machines than the old prairie windmills, but the principle is the same. Both capture the wind's energy. Okay, here's how it works. First, a wind turbine blade works sort of like an airplane wing. Blowing air passes around both sides of the blade. The shape of the blade causes the air pressure to be uneven, higher on one side of the blade and lower on the other. And that's what makes it spin. The uneven pressure causes the blades to spin around the center of the turbine. On the top, there's a weather vane that's connected to a computer to keep the turbine turned into the wind so it captures the most energy. Now, the blades are attached to a shaft, which only turns about 18 revolutions a minute. And that's not nearly fast enough to generate electricity by itself. So, the rotor shaft spins a series of gears that increase the rotation up to about 1800 revolutions per minute. And at that speed, the generator can begin to produce electricity. So, why are wind turbines so tall? Well, the higher up you go, the windier it is. More wind naturally means more electricity. Larger turbines can also capture wind energy more efficiently. The blades can sweep a circle in the sky with a diameter longer than a football field. Now, what's really cool is that even a small wind farm, like this one in Wyoming, can generate enough electricity to power more than 9,000 homes. And larger farms can provide much more clean energy for our homes and businesses. And it's not just on land that turbines can capture the wind. Our oceans and the Great Lakes provide a reliable and consistent source of wind that we can capture and turn into electricity. The Energy Department is supporting innovative offshore wind projects that will help build some of the first offshore wind turbines in U.S. waters. As the wind energy industry continues to grow, offshore development has the potential to significantly boost domestic renewable energy production, especially in coastal areas. With more than 50% of the U.S. population living within 50 miles of a coastline, capturing wind off America's shores has the potential to provide energy to countless homes and businesses. Wind energy, on land or offshore, a reliable and renewable clean energy source, helping move America toward energy independence.
Alright, so that was one short video about our windmills. Now we're gonna watch actually one more. Today we're gonna talk about our top 10. As you can tell, you might see what it is. Windmills could also sometimes be dangerous, like here as you can see, I also made a windmill out of clay. Do you like it? Looks like a good windmill, right? Oh wait. Here's a real windmill. So here, this is actually a windmill. So this windmill has actually as you can see, has a stick. Well, has a stick and three blades here. Wait, give me a minute. My Googles keep messing. Does it? Oh, you know like Googles these days? Like, I have a Google Hub. So here, this is actually a windmill. So let me show you the video here.
A malfunctioning turbine is both tumultuous and terrifying. Here are the top 10 wind turbine fails.
Wait, let me just show you here.
No.
Here, you have, wait. Okay, sorry. So here you have a wind turbine here.
Number 10. The fire failure of Klickitat County, July 29th.
Okay, wait. So now I'm going to show you this one. So this is actually another one here. It says actually wind turbines can also be a bit dangerous, as you can see. You know like how they spin? Sometimes if they spin, if there's too much wind, they can't stop. But they have a breaker. So if it spins too fast like crazy, they'll start to slow down a bit. If that doesn't work, then that's a problem. So let me show you 10 wind turbine fails.
19.
Oh no.
When a wind tumultuous and terrifying. Here are the top 10 wind.
No.
A malfunctioning turbine is
God,
both tumultuous and terrifying. Here are the top 10 wind turbine fails.
No. Okay. Wait. Oh my god, now it's not even clicking. Just click.
Number 10. The fire failure of Klickitat County, July 2019. When a wind turbine fails, the consequences can be dire. And the turbine fail that happened in Klickitat County, Washington in July 2019 is a testament to that. The wind turbine's generator caught fire, causing sections of the turbine to melt. At first, the fire was 300 feet in the air, but these melted pieces fell to the ground where they ignited the surrounding grass. The burning grass then started a massive wildfire. This wildfire, known as the juniper fire, made headlines as high winds and dry conditions forced the fire to spread. It wasn't long before the juniper fire had burned up 300 acres. Firefighters were finally able to get the fire under control, but the failure of this wind turbine caused extensive damage to the surrounding area. Number 9. The Tehachapi.
Uh-oh. What happened here? Oh great, it froze. Wait.
A malfunctioning turbine is both tumultuous and terrifying. Here are the top 10 wind turbine fails.
Give me a minute.
Number 10.
Where were we at?
Made headlines as high winds and dry conditions forced the fire to spread. It wasn't long before the juniper fire.
Stop here. No.
or had burned up 300
Let's
acres.
start from here.
Firefighters were finally able to get the fire under control, but the failure of this wind turbine caused extensive damage to the surrounding area. Number 9. The Tehachapi turbine failure. On May 2nd, 2009, a wind turbine began to spin out of control. The turbine was in the Tehachapi area near Highway 58 at the Sand Canyon Road intersection. The turbine was only 1,400 feet from the highway, so when it started spinning, the highway was closed down. The blades of the turbine spun so quickly that onlookers couldn't even see them. The turbine was owned by AES Company, and it's not known what caused the failure. Employees were helpless as the blades spun. They were told that the only way to stop it was to wait for the wind to die down. If the turbine had broken apart, it could have become very dangerous, which is why the highway remained closed until the turbine was under control. Number 8. The Fenner Wind Farm failure. There are 20 wind turbines located on the Fenner Wind Farm in Madison County, New York. But on December 27, 2009, one of the wind turbines suffered a catastrophic failure. The turbine, which weighed 187 tons, fell into the middle of a field. Experts were brought in to investigate. The wind farm was shut down while the investigation was underway. The turbines were reinforced with steel foundations and truckloads of cement, and the wind farm was soon reopened. But a formal report was never released, so no one knows what caused this massive turbine to succumb to such a failure. Before we move on, be sure to subscribe to Daily Top 10s with notifications on so you don't miss any of our videos. Number 7. The Broken Blades of Perkins High School. In January 2009, a wind turbine at Perkins High School in Ohio failed when a blade became detached. The blade dislodged from the rotating hub, and a nearby parent who saw the failure quickly called the school authorities. Luckily, school was not in session at the time, and no one was hurt. But parental concern grew, as this was the second time in 2 years that a wind turbine at the school had failed. There are 3 turbines at the school, and only a little while earlier 3 blades broke free from a different turbine, causing fiberglass to fly in all directions. The wind turbines are manufactured by Redriven Power Inc. of Iroquois, Ontario. They inspected the turbines, but claimed that they don't know why these turbines have failed not only once, but twice. Number 6. The puzzling turbine collapse of Shannon Wind Farm. A strange turbine failure had experts scratching their heads at Shannon Wind Farm. The wind turbine, which is owned by Alterra Power Corp, collapsed seemingly out of nowhere, causing personnel to shut down the wind farm. The 119 turbine was not near any buildings or homes when it collapsed, so nobody was harmed. But some people feel that this puzzling collapse is a warning about the dangers of wind turbines. In fact, turbines have been failing all over the world, often without reason. And the Shannon Wind Farm collapse could be testament to the volatile nature and potential hazard of wind turbines. Number 5. The perplexing spinning blades of Scregagh Wind Farm, Northern Ireland. The Scregagh Wind Farm is located near Fintona in County Tyrone on the Murphy Mountain. There are 8 wind turbines on site at the farm. So, when one of the turbines collapsed, people nearby were frightened by the failure. Furthermore, the winds were light that day, so no one was sure why the turbine collapsed. The blades spun out of control, though, and made such a loud sound that they could be heard up to 7 miles away. Luckily, no one was hurt, but extra precautions have been put in place to ensure the safety of everyone who lives in the area. Number 4. The unexplained turbine crash of North Palm Springs. A massive wind turbine in North Palm Springs caused concern when it crashed to the ground on May 1, 2009. The turbine, which stood at 200 feet tall, belonged to NextEra Energy. NextEra Energy is based in Florida, and they operate more than 8,000 turbines all across the United States and Canada. So they were quick to investigate the cause of this failure. However, they didn't find any reasons or structural deficiencies that would cause a collapse like this. The turbine was situated 1,000 feet away from the highway, so it didn't pose any real threat. But still, authorities who arrived on the scene were concerned about employee safety, as anyone nearby could have been severely injured. Number 3. The buckled turbine of Chatham, Kent. When an industrial wind turbine completely buckled at Chatham, Kent on January 19, 2018, the safety of wind turbines was questioned by the media. The turbine was owned by Terraform Power, and they quickly brought in specialists to assess the situation. But the wind turbine buckled in such a strange way that the specialists were left baffled. The turbine collapsed from the center, which is extremely rare for a turbine. Specialists suggested that the failure could have been caused by an extreme load of some kind, but they never specified what that load could be. Terraform immediately shut down all 51 of their turbines in the area as a precaution. But the fact that the failure may have been a civil engineering problem caused the media to question the overall safety of these massive industrial turbines. Number 2. The tragic Delta Winds Piet de Wit wind farm failure. The Netherlands is no stranger to windmills or windmill accidents, but when a massive wind turbine caught on fire in October 2013, the tragedy was felt nationwide. The failure happened at the Delta Winds Piet de Wit wind farm. The top of the turbine caught on fire and trapped two mechanics. The two mechanics, who were only 19 and 21 years old, were at the top of the turbine for routine maintenance when the failure occurred. Firemen and emergency services were quickly called to the scene, but the fire, which was caused by a short circuit, was too high for the firemen to reach. The firemen had to bring in a crane, but by the time they managed to get the fire under control, it was too late. Both mechanics lost their lives in the turbine failure, and the incident caught fire in the media. Experts and wind turbine employees claim that accidents and turbine failures are actually quite common, but that nobody has been paying any attention to them. They claim that the media needs to focus on these types of accidents to make the public aware of just how dangerous wind turbines can be. Number 1. The haunting Hornslet wind turbine failure. When a wind turbine was making strange noises on February 22, 2008, engineers were called to the scene to assess the turbine. The engineers confirmed that the strange noises were being caused by worn brakes. They fixed the brakes and planned for further inspection at a later date. The turbine was restarted. But when the wind picked up, the turbine began making strange noises again. Personnel turned on the air brakes at the top of the turbine to try to control the blades. But the blades began to spin like crazy, and they couldn't control the speed of the rotors. Fearing catastrophe, the entire tower was evacuated, and the police were called in. The police secured a huge area around the tower to ensure that no one was in the vicinity of the turbine should it break apart. The turbine continued to spin out of control, and only 2.5 hours after the strange noises had started again, the entire turbine failed. The blade completely disintegrated, and debris from the disintegrated blade was tossed hundreds of feet into the air. The event was caught on camera by men from a nearby farmhouse, and the haunting footage of this colossal fail went viral on the internet. However, it was the first failure caught so eloquently on camera. The turbine was fixed and was put back into operation in June 2008. But nearby residents are still unsettled by the potential danger of the nearby wind turbines. The epic fail of the Vestas turbine and the fact that it was caught on camera has earned this wind turbine failure the top spot on this list of top 10 wind turbine fails. Check out our previous videos on the top 10 abandoned real estate developments that failed and the top 10.
Right. So that's our top 10. So yeah, that's pretty much what our top 10 is. And so basically, windmills could sometimes be a bit dangerous, as you can see. So yeah. Oh, wait, no, not yet. No, no. Okay, yeah. So they can also sometimes be a bit dangerous. So you should always don't put all your hopes into these things, windmills. Just never put your hope into this cup. Put it into the windmill, or half of it. You never know when the windmill could do something like this. Bang, bang. Ah, my keyboard. Okay, so yeah, you never know when your windmill can break your keyboard. Okay, so yeah, that's pretty much all I'm gonna say about windmills today. I hope you liked my video, and if you did, please click the like button and subscribe to my channel down below. Bye for now. Inside Out, signing off. Be careful in windmills.